Hey guys, welcome to Daily Bytes. I'm going to describe about the Python 3 dot features. Today's topic is Walrus operator. Python is released before 4 weeks. It's a new release of Python 3.8, and but it is still in development phase. And we are just going to test the beta version and also uh, talk about all those enhancements which were introduced as part of Python 3.8. Python Walrus operator is an enhancement proposal which was introduced as a part of PEP 572. So it is informally known as the Walrus operator. When the developers were developing it, and during the discussion of the PEP, the operator became informally known as the Walrus operator because it resembles the eyes and tooth of a walrus. Its formal name is nothing but an assignment expression. With the help of the assignment expressions or the Walrus operator, we can just assign a variable with an expression. Here, the expression means any sort of statements which contains a value, any sort of evaluation result. See, for example, if you have a if condition which has a larger evaluation result or conditional evaluation result, so you can just minify it and assign it to a temporary variable which can be referenced at a later point of time during the execution of the program. This is called as the Walrus operator. This is all about the Walrus operator. So I have added a picture of PEP 572 assignment expression, which was stating all the necessary information. So it also described about the author status, etc. So this is not an important slide. I'll just get. So why do we need a Walrus operator? So you have to remember these 5 points of using a Walrus operator and why it is used. So we can just have a descriptive name to be used in place of a longer expression. This means if your if statement has a very long expression, or a for loop or a while loop or etc., which has a very longer expression, so you can just use a descriptive name to express the program in a more intuitive fashion. So this is why the Walrus operator was introduced. And the second point is you can just name subparts of an expression, and so that the debugger will actually pick up the results and show it as the temporary results. And the third point is minimizing the Hazen bugs. What do you mean by the Hazen bugs? We as a programmer, we introduce a lot of bugs during testing, for example. So if you're explaining someone, yeah, if you're finding bugs in the code and you add a lot of print statements or temporary results or anything which is not necessary in the program, you leave it astray. The next developer comes and he's unable to identify which statements are necessary and which statements are unnecessary. So this will cause a lot of variations and bugs in the program, which is also introduced during testing phase by the developer himself. This is also called, this minimizes the hidden bugs because you can assign temporary variable, and we can also know about the evaluation results without the cause of without using too many temporary variables. So I'm coming to the Walrus expression operator. So here I have declared a string. This is a string and more than 3 characters. This is a string more than 3 characters. So I'm just evaluating the expression, which is length of A. This means this becomes an expression. You can give any expressions with the math functions or maybe probably a longer expression which will do. And here you have the Walrus operator, which is n is equal to length of A. So this is greater than 3 and it prints an f string, which is a formatted string again, so which is long. So it just prints the n value here of list is too long n elements expected, which is lesser than 3. So this means the Walrus operator here will store the temporary result of the expression, which is length of A. I'm just going to the next slide. This is before using Walrus operator, and the code is not up to the mark, and I have not followed the coding standards in order for the demonstration. So I have a before and after Walter's example. Here you have a text having text, of course. It is initialized lazy fox jumps over the wall to catch sheep. Okay. So I'm just going to check the text for the presence of fox and the sheep. So it's a regular expression compile. So with that, I just also want to import the regular expression. There is nothing on the separate because it's separate. So yes, so there are two patterns where the fox jumps and catches a sheep. If this is found, okay, so if this is found, this pattern is found. So the actual what is the match and match two are temporary variables, and if match one and fox found, and if match two sheep found. This will technically check for the patterns which are compiled by the regular expression, and then it actually checks for fox and sheep. If fox and, if fox and sheep is found in the subsequent statements of if, and then it prints the necessary things in order. So you can just use the Walrus expression to have temporary assignment of matches, and also you can just print the matches at a later point of time. So this simplifies and minimizes the code, and it's also readable. So you have to only match for two, and then if fox is found and if sheep is found, and parent one stores fox and parent two stores cat sheep. So you can compile this expression in order to arrive at the result. So this is very simple to use, and also it saves time, and it's very intuitive. You can just explain the developer in one statement what you intend to do. So it is clear that you can just use Walrus operator for storing the temporary results of an expression. So you have to also consider the Walrus scope. The scope it is self-explanatory because it lies within the execution block of the program. So this is to introduce a new scope, and it is very self-explanatory because it just resides within the current scope of the program. It's not a global declaration for the target. So, precedence of the operator, you have to just know about the precedence level of the operator because it is necessary for you to know that it has the high precedence over comma. I cannot say it is a high precedence, but always you have to. It is also described in the PEP specification that it is slightly more than comma because it tends to shift to the right. So there are some more categories of the Walrus expressions. You cannot use it along with the comma. Then I'll describe those expressions at the later stage, and you can also refer to the PEP specification for more information. So it also has a higher precedence. It has a lower precedence than equals. So these are the two things you have to remember while using the Walrus operator. So I have listed over here in a very simple slide. So what is invalid and what is valid? As Walrus operators only introduced for expressions, which has to be used in if statements or while statements or many other statements. And using this is invalid because it's not an assignment variable. It doesn't allow you to assign a direct variable to it, or it is not intended to be used outside the expression context. So you have to always use brackets to specify a valid alternative of the Walrus expression. Sorry, Walrus operator. So you have certain invalid cases and valid cases, and PEP specification has all those valid and invalid results listed over. They have extensive examples on those. You can also refer to them. So whenever you have an alternative of the valid alternative for the invalid expression, which is listed before, is always use you have to use the braces. It's synonymous with the context of expressions. So you can also use in position variables. This is valid. So if you call a function, you can just use the Walters expression as an in position variable. And you can also have certain alternative results because you can always choose between the Walrus operators and the valid of ones. And yeah, I'll be demonstrating certain programs. So let's go to the programs. So here I have a demo. I have certain demo programs which can be debugged at this point. So why we're using Walrus operators? So if I just start debugging this particular program, it's Python. I'm using Visual Studio Code for it. You can just choose your own IDE because it also comes up with a lot of new plugins. So you can just go ahead and install all the expressions which are, sorry, extensions that are needed for Python. So we can just start it. This is all about choosing your own ID. And I've just set the interpreter as Python 3.8, so you can also choose your own interpreters. Otherwise, you have to choose the Python 3.8, and you're not allowed to choose any other interpreters. There's a mistake. Yeah, and yes, of course. So this is first use case. We have the Walrus operator. This is a very simple program. Well, like I'm using the old style, but here there are sub expressions, which is assigned to an expression. So this sub expression will hold a result, and sub expression one will also hold a result. So let's check what we have in the debugger. So in Visual Studio Code, you can have a debugger, which is listed over here. When you click on this, everything will be listed over here, and you can also choose different things. The first thing is Walrus operator. Yes, I can start with the next point. Yes, so this is printing true, but I will not be able to, read this whole expression and identify what is needed for me. So in order to simplify, I have the Walrus operator. Yeah, I know the result of sub expression. I also know the result of sub expression one. This is very intuitive because you can also see it in the results here. So sub expression 0 and sub expression 1. Uh, these can be used reference at later stage because the intermediate results are stored to a variable. So it is just like any other variable. You can delete it, or you can also manipulate those variables and use it at a later point of time. So this is the example which I presented in the presentation. So you have a very huge set of patterns and search, text, and if conditions and else. This can be written in one single line. It gives the same results almost. So if you want to have the fox and sheep found, you can just have this on one expression which states whether it's found or not. And if it's found, I have the matches also stored in the match variable. So it's clear as it gets. I have a comprehension list. Can be used in case of comprehension list, but not a direct assignment, but you can use otherwise. So I have a demo function, which is returning me the list of numbers based on the length, which I specify as an argument. So when I have five, it'll if I just give five, so it'll return five numbers. So I'm just using the Walrus operator to assign it to a function. And then this function result, this is the Walrus intermediate result, can be, assigned to another comprehension list. I can also manipulate this result in order to assign it to another comprehension list. Let us check. So this is compiling all the patterns. You can just come down. And this also has match one. Okay, this is the previous one. So here, if I just go to the comprehension list, it has 1, 2, 3, 4, 5, and this is stored as a result of function result, which has 1, 2, 3, 4, 5. And then again, you can just add function result plus 9 and 10, which is a you can just use the context here because whenever you assign a demo function to the functional result, it holds the state and it holds the value of the variable. And this can be used inside a function or inside a comprehension or inside any other data structure in order to arrive at conclusion. Okay, this is very intuitive and also it reduces the complexity of saving this in temporary result and manipulating it again. So it also reduces the number of lines of code. This is a very simple example which I provided in the PowerPoint presentation, which also talks about the number of characters. So here you can see all the results here. We'll just go over to the next line. Yes. So the list comprehension and the list is too long. It all this is really very useful because it holds the intermediate results and it is used only in case of expressions, and you have to always remember about the brackets which you have to use in order to use the Walrus operator. That's it from me, and yeah, see you tomorrow.